Hello everyone. Let's have a look on chapter number 5 of physics, that is about magnetism and matter. So as the name suggests, this chapter is all about magnetism of the matter. So it is a very short chapter and now is only one important derivation in this chapter. So you don't have to be worried about this chapter. So in this particular lesson, its derivation is about horizontal and the vertical components of Earth's magnetism. That is about horizontal and the vertical components of Earth's magnetism. So this particular derivation is important from this chapter for the examination point of view, and it includes some basic concepts regarding geographic meridian. That is about geographic meridian. So what is this geographic meridian? It is a vertical plane which passes through the geographic axis of the earth. So the geographic meridian, it is a vertical plane which passes through the geographic axis of the earth. And next is about magnetic meridian. So it's just like that. Magnetic meridian, it is also a vertical plane which passes through magnetic axis. Yeah. So as the geographic axis passes through geographic axis of the Earth's magnetism, and similarly the magnetic meridian, it is a meridian or a vertical plane which passes through the magnetic axis of the Earth. And next is about magnetic declination. So what is this magnetic declination? So it is a angle. Declination, it is an angle which is represented by theta. So the magnetic declination is the angle between the geographic axis as well as the magnetic axis, and it is represented by theta. So it is the angle between these two. About angle of dip. That is about angle of dip in the article of Earth's magnetism. So angle of dip is mainly represented by phi, or you can also write it as delta. This is the representation of the angle of dip. So let's say we are taking delta only. So the angle of dip, that is delta, will be equal to tangent inverse of BV upon BH. This is the main particular formula of the angle of dip. So here the delta is angle of dip, which is equal to the tan inverse BV upon BH. And what is this BV? It is the vertical component of magnetic field, and BH, it is the horizontal component of magnetic field, and B over here is the magnetic field of Earth, or you can say Earth's magnetism. So now there is another relation between this BH and BV. So that is about B is equals to square root of BH square plus BV square. So what this relation suggests, that the total magnetic field on the earth is equals to the square root of the square of horizontal component plus the square of vertical component of magnetic field. So we have discussed in this article 4 main topics. That is about geographic meridian, magnetic declination, and at the end we have discussed about angle of dip. So these are main key points in this article. You must go through this. This is all about this chapter, and see you in the next